Alright, this is going to be my lab report for Lab 3 of Physics 2211. So the purpose of this lab is using computer models. We are going to find the mass of a black hole by analyzing a star's orbit, and then using that mass of that black hole, we are going to compute the velocity of a spaceship that would be necessary for said spaceship to avoid colliding with the black hole. To do this, we're going to need to use Newton's second law, and we're also going to need the universal law of gravitation. And later on in the lab, we're going to find that the mass of the black hole is going to be 1.5 times 10 to the 34th kilogram, which is, of course, massive, and is what you would expect for a black hole. And then the velocity for the spaceship that I found is going to be -3 times 10 to the 7th and 6 times 10 to the 6th meters per second in that vector. For this formula, we're going to need that force is equal to the rate of change of momentum. We're also going to need to know that force net is equal to the sum of your parallel and perpendicular forces. And you can find the perpendicular force by delta R, which is equal to n hat times mass velocity squared over R. And if force parallel is the motion of the object, which is equal to the rate of change of the magnitude of the momentum over time times p hat. We're also going to need to know our velocity update formula, which is Vf equals Vi plus force over mass times delta t, in our position update, which is going to be Rf equals Ri plus velocity average times delta t. And then, of course, we've got universal gravitation there, which is going to be the force of gravity is equal to the gravity constant times the mass of the larger object times the mass of the smaller object times the radius of the two squared. Why only the force of gravity? Well, because in this system we're modeling from space, we know that there is no air resistance, there's no objects influencing the spaceship or the star that's orbiting the black hole, so we can assume that it's only gravity. We know that the change in motion occurs as a result of the force perpendicular, meaning any change in direction comes from the force perpendicular. The change in the magnitude of the speed, it comes from force parallel, because force parallel is in the direction of the vector. Then we can also assume that the force of gravity is non-constant, therefore final velocity can be substituted for the average velocity throughout this formula. To find here's the initial conditions. Knowing that the universal gravity constant is going to be 6.7 times e to the -11th, we're also going to know that the mass of the star is that, and then delta t here, which comes from converting a day to seconds. Then here's the code for the black hole. You can see how we find the change in net force right here using dp dt. As was discussed earlier, this is the mass of the black hole, and then, of course, the magnitude of the force is going to be also huge, but it's notable that the force parallel is going to be much lesser than the magnitude of force that is trying to turn the planet. But even so, they still add together to result in this vector here. And then for our initial conditions, we're going to use that mass that we calculated in the first part, and then we're also going to just leave everything else as is. For the velocity of the ship, it's found using these simulations over here. To find the actual speed of the ship, this was just found basically as a result of plugging in numbers and running the simulation to check. But you can see here that the force net parallel and force net perpendicular are found right here in this line. As we said, the result there, the velocity is going to be this vector here. And then at the end of the simulation, you can see that the spaceship ends up a very long way away from the black hole after not colliding with it. It ends up very far away. So there are definitely a few sources of error possible here. Finding mass, the program, I only ran that for the default length that comes with the program, which is 1 day in seconds. In velocity, I also only use the default time step. The velocity also might be wrong, again, because I found that via checking and running the code. There might be a smaller number which yields the same results. And of course, there's also the possibility that the code is just flat out wrong in both simulations. What if you wanted to orbit the black hole? This can be done by finding the correct speed vector, which would result in essentially as the object gets pulled in, it moves and fills in the void. I did not figure this out. I could not find a number that did this. And what does this mean? So force net parallel is equivalent to the forces in the system. So we can see that the direction of the motion comes from force parallel, and force perpendicular is directly a factor in changing the direction of the motion.